The graph to the right is the uniform probability density function for a friend who is X minutes late. Find the probability that the friend is between 15 and 20 minutes late. So, do you remember what we do here?
Let's see. Mm-hmm. I don't think so.
Okay, so we are only interested in these horizontal values. So they go from 0 to 30, right? So that is our whole total, the 0 to 30. And we are asked how much is the probability that it's between 15 and 20. So between 15 and 20, okay, let's draw it on the number line. So yeah. So the total is between 0 and 30. And we are asked that it's how much is it between 15 and 20. So 15 will be here. Let's say 20 would be here. So this is what we are asked. So what would you would do the length of this interval. So what's the length of this interval, the one from 15 to 20?
Wouldn't it be 5?
Right, so 20 minus 5, 20 minus 15, so that's 5. And what's the total length of the interval from 0 to 30?
From 0 to 30, it's 30.
Yeah, so it's 30 minus 0. Basically, to get any length, you divide, you take the difference of the endpoints. So, what do we get for this?
5 divided by 30.
And I think they want decimal.
0.167.
Now, when they ask, there's a 10% probability of the friend arriving within this many minutes. So that's the reverse question. So here, what was the total length of the interval? Overall length?
30.
30. So you just multiply that 30 by 10%.
Okay.
What do we get?
3.
So when they are asking for the probability, as they were in part A, you do the length of the interval they want divided by the total interval length. And when they have given you they gave you the probability in part B, they say it's a 10% probability, then you just multiply that by the total interval. Okay. So, okay, what do you think about this one?
I think we would be using one of the calculators
Which one?
and do between.
All right, so which calculator?
Would it be normal?
Yeah, why?
Because it's normally distributed.
Mm-hmm. So stats stat crunch. So stat calculator normal, and it was between something, and okay, the mean was 64.1, standard deviation 2.7, and between 60 and 70.1. Point 9224.
Let's see. Would we have to put this information in StatCrunch to see the shape of it?
No,
No.
here we use that, so they don't tell us that it's normal, right?
Right.
But remember that rule that when the sample size is bigger than 30, then the sampling distribution is normal. The
Okay.
main distribution may not be normal, but the sampling distribution is normal, and that's what they're asking about.
So this one will be
Approximately normal.
yes, D.
Okay. And then how will we do this calculation, the mean and standard deviation? Do you remember what the mean and standard deviation for the sampling distributions are?
I
You,
don't
you
think I do.
Is there some formula for that on the formula sheet? The mu x bar and the sigma x bar?
Let me see. Oh, I don't see it.
No? Okay. So, um, do you remember that one of them stays the same and one of them is different?
Yes.
So which one stays the same?
Um, I believe the mean.
The mean stays the same as the original mean, so that's 70. And now do you remember how does the standard deviation change?
Is it just subtracted by 1?
No, that's the degrees of freedom.
Mm.
So standard deviation is just the original standard deviation divided by the square root of sample size. So
Okay.
square root of 49 in this case. So this would be 1.
Okay.
And then what do we
And
do with part B?
this is where we would have to use StatCrunch, right?
So how?
Um, let's see. Mm,
So we will use the result of part A. What did we find in part A?
the distribution is approximately normal.
So then what do we do?
Use the normal calculator.
Mm-hmm. And which mean and which standard deviation will we use?
Wouldn't we use the ones we found?
Because they are asking for X bar, and so we would use the ones for the X bar. So 70 and 1, and we want greater than 72. Go to standard, greater than 72. And as we've been repeatedly saying that in normal distribution or any continuous distribution, it doesn't matter whether you are talking greater than or equal to, it's the same thing.
Right.
0.0228. Okay. So p hat, remember what is this a symbol for?
Mm, proportions.
Sample proportion. So how do we get sample proportion from this information?
Proportion stats?
No, sample proportion is something which you could do even 3 years ago. Just read what they're saying and tell me how we get the proportion.
Wouldn't we just divide?
Divide, right? What by what?
351 by 2,359.
It's because it's this many out of this many who have the tattoo. So 351 divided by 2359, what do we get?
0.149.
So now for the confidence interval, we will do proportion stats because they say construct a 90% confidence interval for the proportion in part B, right? So now we use proportion stats. So it's one sample summary. So what was it? 351 out of?
2 something. I can't remember.
351 out of 2359. And we want 90% confidence. %. So lower bound is 0.137 and upper bound is 0.161. Once in a while they give this formula sheet as well. Let me see. I haven't looked at it for a while. Okay. So what do you think about this one? How many subjects are needed to estimate the mean number of books within 90% confidence? Within 3 books with 90% confidence.
Since it's wanting to estimate the mean.
No, to estimate the number of books.
Yeah, the mean.
The mean number of books, right? So mean is an important word in the problem. Why is it important?
Isn't that variance stats?
With means, you do variance stats.
I can't remember.
What are the three kinds of stats we use?
Proportion stats, variance stats,
and
is it t-stats?
Yeah. So which ones do we use with the mean?
Is t-stats with the mean?
Because with variance stats are used for standard deviation or variance. But remember, standard deviation and variance are the related things, but mean is something different. So mean is t-stats. So will we use the normal t-stats one sample summary here?
No, it doesn't give us all that.
Yeah. So what are we going to do here with the t-stats? So is it always that we use just the one sample summary or one sample data, or do we use something else as well? Sometimes.
Width?
Yeah, and with sample size, because look, they're asking for sample size, how many subjects. So this is one of those few problems where you have to use the one sample width and sample size. So stats, t-stats, one sample, and width sample size. So the confidence level is 90%. Standard deviation is 14.8. The sample size has to be found out because they say how many subjects. And so it means we need to know the width. So do they give us the width of the interval?
The previous year? I don't know if that would be
Oh,
good.
width of the interval is about the number of books. The previous year is just a point of time where you were studying. That is not a part of the calculation.
The books is.
Yeah, so what do they mean by within 3 books? What is this 3?
Oh, I see that. Previous year within 3 books.
I think we had a discussion about this within thing at an earlier time in our lives.
Um,
And I think I was giving example of your age. Let's see if you remember what this within 3 thing is. So if I say I can estimate your age within 3 years, what am I saying? I'm saying something like this. I will say that, okay, your age is 18, and but my estimation is correct within 3 years. So what that means is it could be so three years less of 18 is 15, and 3 years more than 18 is 21. So if I say this statement, what I'm saying is that your age is between 15 and 21. So what was that 3 years, which was the part of this statement? What's a term that we use for that in this course? It's a three-letter phrase.
Mm.
Isn't it the margin of error that I'm giving myself? That okay?
Margin of error.
Yeah. So this 3 books here is the margin of error. But the box is asking us for the width. Yes, we have spotted that we have the margin of error, but we need the width. So
Mm.
you remember the relationship between the interval width and the margin of error?
Isn't it? We would, if we had the width, we would divide it by 2 to get the margin of error.
Right, but here we have the margin of error. So what do we do to get the
Will
width?
we multiply it by 2?
Uh-huh. Margin of error is half of the interval width. So uh, interval width would be twice the margin of error. So 2 times 3, 6.
6.
So 68.
Mm.
And then, if you are using StatCrunch, then you don't have to worry about this round up. The StatCrunch does the rounding. So this is a picture that you should remember, not just for this problem, but it helps in some other problems as well. So the picture is that you have the lower bound here, you have the upper bound here, and in the middle, you have the point estimate. Point estimate is the midpoint of the interval. This half length is the margin of error. So it turns out that the margin of error, so sometimes you may have to calculate margin of error when you are given the upper and lower. So you need to remember this margin of error is u minus L divided by 2, because u minus L gives you the interval width, and then you divide it by 2 to get margin of error. And then we can remember that width of the interval is 2 times margin of error. And then how will we get the point estimate if we are given the lower and upper bound?
Mm. Is the point estimate just what's in the middle?
Uh-huh. So what's the formula for it?
Mm.
And again, that formula for the midpoint, you knew that even before coming to this class. We do one of your favorite things, which you wanted to do at so many other places yesterday.
Just divide by 2.
Divide what by 2?
The entire interval length.
No, that gives you the margin of error. So midpoint, you divide by 2, but divide, what should we have on the top?
L plus U.
Uh-huh. So it's point estimate. See, once you have this picture in mind, this L and U and point estimate in the middle and E like that, then even if you forget the formulas, and you can recover them if you have the understanding. Okay, so what do we do here?
Wouldn't we use T stats?
Because 95% confidence interval about the mean, right?
Right.
Was that your reason for using t-stats?
And it says, well, I guess that's not
Yeah.
really a, but
Not because of this, because they may give the mean and standard deviation in some other stats as well, but it's what
right.
confidence interval you want, right? The confidence interval about the mean. So this is a symbol for the mean. T-stats. So the sample mean is 18.3, standard deviation is 4.1, size is 35, and 95% confidence. Stats, T-stats, one sample summary. Sample mean 18.3. And 95%. 16.89 and 19.71. Oh, what do we do here?
open the data in StatCrunch.
And then
Um, it's talking about a normal probability.
you have to read the question part of the problem. Where are they asking the question? Or where are they asking you to do something?
Okay, so construct and interpret a 95% confidence interval for the standard deviation pH of rainwater in this region. So variance stats.
Right. Standard deviation interval means variance stats. So stats, variance stats, one sample with data. So we select the column and then what else do we do?
The confidence interval.
99.
Compute.
So which choice do we pick of these?
The one that says sample standard deviation between.
Why?
Because it's the other two say population, and we know it's not population.
Confidence interval is always about population.
What?
Sample value, we know exactly what it is. We know it's 0.323. So we're not saying that the sample is between this and this. So remember, confidence intervals are never made about the samples. They predict the population parameter.
Okay, so it's not the one that says sample.
Yeah, that's the one that was not for sure. So now the question is, which of the others are talking about a confidence level?
B.
Yeah, B is the only one that's talking about confidence, right? Okay, so now I just select B and put this lower limit and upper limit.
I believe so.
A little bit careful. Which stats did we use to do this problem?
Variance.
Variance stats. What was the question?
Interval for the standard deviation.
Yeah, we used variance stats to get an interval for the standard deviation. Remember variance stats, when you use variance stats, they will give you the interval for the variance, right? Natural
Right.
thing. So is the interval for the variance the same as the interval for the standard deviation?
No.
So how do we get standard deviation if we have the variance?
Don't we do the square root?
Yeah. So these are the variances and we will square root them to get the standard deviation. So what's the square root of this first one? And if the final answer is needed to 3 decimal places, then usually the safe thing to do is to take 1 decimal place more for the intermediate answers.
Okay, so 3, so go 4. So for the lower limit, it looks like 0.207.
Okay, and the upper?
0.665.
0.207 and 665.
So
Oh, that's your favorite problem. There's one word in this problem which is the key word about which we had a lot of discussion last time. Like last time, I mean a while ago. What's that word? Hmm,
majority?
Majority. So let's see. Do you remember what majority means?
Uh,
Oh, it'd be so funny if you've forgotten it again.
um, a majority of adults. So that means almost all of them. It's like a majority. I don't know.
Majority is almost all of
Over half. Or,
over half. Yeah, over half is not the same as almost all. So, like, let's say you're having the election. So let's say it was a simpler system than the one we have in America. And the simple system is that you just count all the votes instead of this electoral college thing. And whoever gets the majority of votes will win. So then how many votes do you need in order to win?
isn't it like it's more than 50? It's
More than
like
50%, yeah. So that means majority is more than 50%. So then what number do I put here? Okay, for what sign do I pick?
um, for the first one, wouldn't it be the equals?
Null is always equals. And what number?
Would it be 50?
It's percentage or proportion, so you have to enter the proportion. So 50% is what proportion?
0.5.
0.5. And then over here, Now, majority means
Would it be greater than?
greater than 0.5, right? Yeah, now I understand why you always get into this with the majority, because in our everyday language, we've gotten into the habit of saying that, yeah, thinking that majority means that like an overwhelming number, right? Most of them, that's why you said that. But like mathematically, as long as you're more than half, you're majority. So, okay, so now how do we find the p-value?
Mm, it's not proportion stats.
Why not?
I don't think so.
why, why don't you think so? And the remarkable thing is that you said what you think it is not.
I know.
So what made you even think of proportion stats?
Because it's p-value, but a lot of
P-value is in all the three situations.
right.
So
Um,
how do we decide which one is it?
would it? The p in the first part. So wouldn't we
It's a
use?
hypothesis test which tells you which one is it. So this P tells you that it's proportion stats, not the big P.
Right.
Okay. So stats, proportion stats, one sample summary. Okay, so what are the successes and observations?
Let's see. 534 would be successes, and observations would be the 1034. And then
And what?
for the hypothesis, it's already 0.5, but we need to change the second one to greater than.
Mm-hmm. So 0.1452. 0.1452. And now what is our famous decision rule about the rejection or not rejection?
We compare it to this 0.05.
Yeah, so what's the rule? When do we reject?
When it's greater than?
So say the full statement when what is greater than what?
When the p-value is greater.
Then
I forget what that's called.
alpha.
Alpha.
So we reject when P is less than alpha.
Of course. Reject.
It's less than alpha. Okay, so then what do we do here? Do we reject or do we fail to reject?
Reject.
Why?
Um, isn't 05 greater than 14? Well, maybe not.
Really? O5 is greater than 14.1452?
No.
Which one is greater?
Okay, p-value is greater.
Right.
So we do not reject.
Right. Is greater than alpha. And when we do not reject, then what about the evidence?
There is sufficient evidence.
When we do not reject, we do not have evidence. I
Do
love
not.
it when how you always say this kind of thing wrong whenever you have two
Oh,
choices.
so do not reject. There is not.
And they go together. The do not reject means you do not have evidence.
Okay. Um,
Okay. So here you also have to pick the symbol. What are we testing? Are we testing proportion, standard deviation, or mean?
mean,
Mean, why?
because it's asking about or telling about right here the mean waiting time.
Yeah. So which is a symbol for mean?
Um, the one that looks like a U, a backwards U.
You have no love for the Greek alphabet.
I can't remember any of the names.
Equals in the null. And which symbol do we pick?
I believe less than, because it says believes will decrease wait time.
Okay, how do we find the test statistic?
First, we'll open this data in StatCrunch.
Hmm,
And I don't remember.
Just stopped after opening the data instead.
Well, I was looking at the options.
Mhm. So, do you believe that test statistic is done through one of the three stats?
I don't think so.
Don't think so? Isn't it sitting next to the p-value always?
Um,
So, let me show you the window I'm talking about. So when you look at this StatCrunch window, isn't test statistic always sitting next to the p-value?
okay.
So if it's sitting next to the p-value, doesn't it mean you have to do the same thing to find it as you do for the p-value?
Right.
Right, and you know that for the p-value we use the stats.
Yeah.
So now which stats?
Would it be Z stats?
Do we ever use these stats?
I just don't feel like it would be T.
Why
Or
not?
I don't know. Because that's the mean.
So what do we use for the
Oh, but we're talking about the mean waiting time.
so which stats do we use for the mean?
Right. T stats.
Yeah.
I don't know what I was thinking.
So stats, T
So,
stats. Yeah, once I found a student who somehow was always using Z stats instead of T stats. I said, who taught you to use Z stats? And then
no.
the thing is that a lot of times you get it right even with the Z stats, but not always. So
Right.
once he got it wrong, and then we discovered that he's been using Z stats all his life.
Oh no. That's something I would do.
So T stats, one sample with data and hypothesis. Oh, here's one thing. If you use the correct stats, it gives you the correct symbol. Look at this. So like if you had opened like the variance or the proportion, it would have given you the other symbols, the ones for the proportion or for the standard
I
deviation.
didn't think about that.
Yeah, that's also a good way to remember. Well, the thing is, if you forgot that you use t stats for the means, then you probably forget what I just said as well. Then you look at
Yeah.
because I've said that much more. That so yeah. Okay. So hopefully you'll remember it when it really matters.
Yeah, I hope so.
Yeah, I mean it's good that we make all these mistakes during the reviews and
Yes.
practice. Okay, so it's equal to 83.7 and less than. So p-value is 0.11, but they're asking for the test statistic, which is negative 1.317. and p-value was 0.1101. 0.1101. Okay, so now let's see if you remember. What's the criterion for the decision?
Okay, we need to know what alpha is.
Mm-hmm.
And I think that was in the first one. Well, there is alpha.
Mm-hmm.
Um,
So what's the rule? Let's review the rule again.
we reject it if the p-value is less than alpha.
Good. So
So right here, the p-value is greater than alpha, so well, we do not reject. So
yeah,
p-value is greater. Would it be is not
right.
sufficient?
Mm-hmm.
So
And
D.
not reject that there is not sufficient evidence.
Okay. So we would use variance stats.
Mm-hmm. Because of the standard deviation in the hypothesis test. So stats, variance, one sample summary. Okay. So what do I put for sample variance?
25.7.
Is that the variance?
No, that's the standard deviation.
So how do I find the variance?
Do you square it?
Mm-hmm.
Okay.
25.7 squared. And size is 25. Okay, so then what else do I do?
Make sure the hypothesis test is right.
So what do I write?
So we need it to be 30 and the second sign to be less than.
Be careful. What is the box asking for?
Population variance.
So is that variance?
No, that's standard deviation.
So
So we would square the 30.
mm-hmm. Will be 900. So test statistic is 17.613 and the p-value is 0.179. So what's the conclusion here?
Um, it would be since the p-value is greater than the level of significance, the researcher should be will not reject. I got something wrong.
Oh, he did something wrong?
Let's see. Oh, let's see. Hmm. I don't know.
Not finding a mistake?
Well, I found one mistake. It's the test statistic is 9.615, and I accidentally put 9.165, so I flipped the 6 and the 1,
Okay.
and I flipped it, and it's still wrong.
What is wrong?
I don't know, it was just telling me that it was wrong.
Doesn't it point out where the mistake is? So what were your numbers?
Um, for the size, 22.
Okay.
Standard deviation was 20.3, but I squared that and got 412.09.
Okay.
And then
The test.
I had 30 as my hypothesis test.
Then you
And then
square that.
I did, and it was 900.
And then you use the correct sign.
It's less than.
Yeah.
That's what I had.
And then what do you get for test statistic and p-value?
For my test statistic, I got 9 0.6154333.
Okay.
And then p-value 0.0165.
Oh, you need 3 decimal places.
Oh my word. It's been being 4. I guess that's why I did
Yeah,
that.
they keep tricking.
Yeah, okay. My p-value is less, so it will reject. Yep, that's what it was. Had 4 instead of 3.
Although you are doing a better thing by doing 4 places than 3, but you're not doing what they are telling you, right?
Right.
Mm,
Hmm. I remember this in the homework,
yeah.
but I
First
think I
part should be
remember.
easy.
Mm. So, how do you tell if it's like the second sign in this problem?
What do you mean, second sign? I didn't understand what you're asking.
Well, would it be the one it gives you where it says test weather and then it's the greater than?
Yeah, what else is there?
Mm, nothing. So it would be A.
Mm-hmm. Oh, you were trying to find less than or greater than in the problem?
Yeah, at first I didn't see it, but then I saw it.
Okay. Mm, okay. How do you find the test statistic?
Mm, for this one, I don't think I remember how to.
It's the same rules as for the one variable. All the rules are still the same. What are we testing?
Hmm.
How many things do we test?
Here, aren't we testing 2 things?
I mean, how many different kinds of things do we test, like for in the one variable? In the hypothesis test, what are the 3 things that we test normally?
Like the test statistic, the p-value, like
No,
that.
no, no. Well, what parameter do you test? What are the symbols that we encounter in the hypothesis test?
Like greater than, less than. I don't know.
I think you've now said everything possible, and there's only one thing left, and that's the right thing. What is it?
I don't know.
Hmm.
Uh,
Okay, what are the three kind of stats do we use?
variance stats, proportion stats, and t stats.
Okay, and when do we use which?
Um, t stat, it's mean.
Okay,
Variance stats when it's standard deviation or variance.
okay.
And proportion stats when it's a proportion.
So what are we testing here?
Mm, a proportion since they're p's.
Yeah.
Okay.
I it is for some reason you never look into the hypothesis test to decide which.
No, I don't know why I don't.
You're looking everywhere else except the one place where it is
Yeah.
telling you what. Okay, so proportion stats. So tell me the whole command.
Would we do two sample?
Yeah. So stats, proportion stats, two sample with summary. Okay, now tell me the data here. What do I enter?
Um, so would so it would be 129 for the successes and 247 for the observations.
Right. So X is always a symbol for successes. 247.
And then for the next one, 132 for successes and 314 for the observations.
Hmm. And then what do we do here?
We need to change the sign to greater than.
In two variables, all you need is you just have to look at this sign.
Okay.
All the numbers are already there. So test statistic is, that's very annoying. It's hidden. I have trouble getting this. Okay. So test statistic is 2.44 and p-value is 0.0082. Okay, the decision. What's the decision? Hmm,
C. Um, D.
why?
Because p value is less than alpha.
right?
So there
0.0.
is evidence.
Mm-hmm.
So we will reject it since it's
Right.
like,
So you finally said alpha.
I remembered it.
Yeah, and you said it so well that like we've been missing all along. You're saying the name of the Greek alphabet. Okay, so let's see how you pick the hypothesis.
Okay. So it's probably going to be D. Yeah, I couldn't see it, but yeah, it is.
And then how do we find the p-value?
We're going to use T stats
Right.
since
Mm-hmm.
up here it's using the mean
Yeah,
symbol.
you finally got it right in the last problem.
Yeah.
Okay. Uh,
T stats.
so two samples.
Yes.
Stats, t-stats, two sample with summary. So what do I enter?
Um so for the first one it's going to be 14.7 for mean, 4.3 for standard deviation, and 17 for the size. And for the next one, it's going to be 17.6 for the mean, 4.6 for standard deviation, and 17 for the sample size.
And what do we do with the hypothesis test?
We will, we actually don't have to do anything because the sign is already correct.
Mm-hmm. 0.0667. So 0.067. And the decision.
Let's see. So the p-value is greater, so we do not reject it
Mm-hmm.
because there's evidence.
So which choice is it?
Mm, D.
Yeah.
Oh, there was, yeah, it is D.
Mm-hmm. That does it.
Let's see. Yep. Let's see, this was. All right, we got done early today for once.
Yeah. Although we went pretty slow, but yet it finished pretty early.
Yeah, earlier than usual.
Mm-hmm.
Right. And I'll probably try to start on that other review, and then whatever I can't figure out or just need a review on,
Okay,
uh, we could do Monday probably.
sure.
Yep. Well, thank you so much.
Okay, you're welcome.
Have a good weekend. It's
You too.
Friday.
Mm-hmm. You too.
Bye.
Bye. So, Abby, what do you have?